Hello, and welcome to the third video in my series on plotting and visualizing data using the Julia programming language and the Plots.jl package. In the previous video, we learned how to plot basic mathematical functions that are built into the Julia language itself. In particular, we used the plot function from Plots.jl to plot the sine and cosine function, as well as the log base 2 function. We also learned how to specify our limits for our x markers and our limits for our y markers, or the tickers on each axis. We also learned how to give them specific labels, as well as how to plot and annotate points and text in our figures. In this video, we're going to expand on plotting points via plotting, or not plotting, scattering pairs of data. So what we're going to do is we're going to take x value, I apologize. We're going to take arrays of x values and arrays of y values, which together will make tuples, which we can then visualize in the Euclidean plane. So to begin, let's go ahead and import our necessary libraries. And I'll set my theme to be dark, because that's my favorite. So as you can see, I typed out using our datasets. Our datasets is a Julia package that will give you access to all sorts of data that you can experiment with in your data analysis and machine learning explorations. If you don't already have this package, you can go to the Julia package manager and just simply type add our datasets. Okay, if you type enter, the package manager will load that in for you. I already have this package, so there's no need for me to do that. Now, the specific data set that we're going to be looking at is often referred to as the hello world of machine learning data sets, and it's called the iris data set. To access this data set, I'm going to assign it to the variable iris, and then type data set, and then pass into this function the string datasets, and then comma, the string iris. So this function dataset was imported when we called our datasets, or when we typed using our datasets. Okay, and then we specified we're going to access the datasets module, and inside of that module, we're going to access the iris dataset data. So if I just save this, select all, and run, I see that I have some output down in my REPL. It looks like it's been truncated, so I'll just type iris over again and see that I have a tabular format for this given data. Now, this data consists of 4 measurements represented by the columns of this table, which is a Julia data frames object. So in this column, we have sepal length measurements. In this column, we have sepal width measurements. In this column, we have petal length measurements. In this column, we have petal width measurements. And each of these measurements corresponds to a given species of iris flower. So that the species labels will be contained in the species column. So what are the species? Well, if I type the name of my data frame, iris, and then dot, and then the name of the column I want to access, for example, species, and press enter, this will give me the list of all of the species in that column. Now I see a lot of repetition and I can't see what is hidden by these dots right here. So I'm going to go ahead and convert this array into a set, because sets get rid of multiple entries. So if I do set and then call iris.species, I see that there are 3 values in there, and they're categorical: versicolor, setosa, and virginica flowers. So there's only 3 species of flowers in here. And each of these species, each of these instances of a species has measurements associated with it. So what we're going to do is we're going to take 2 columns at a time one column being the x values, the other column being the y values, and then plot those in the Euclidean plane using the scatter function from Plots.jl. So just to be as clear as possible, I'm going to say capital X is equal to iris dot, I want to access a column. I don't know which one I want to access. Maybe I'll say petal length. Petal length. Okay. And then I'll say capital Y is equal to some other column, iris dot, maybe sepal length, like that. And then I'm going to pass these into the scatter function. The first entry being the x values and the second entry being the y values. Now, if I select all and run by pressing Shift Enter, I get a plot over here, but it's small because my dumb DPI isn't set correctly for my resolution. So DPI, I think maybe 1,000 in this case. I'm back on my laptop. Let's see. Select all and run. That looks a little bit better. Okay. Now, I can see that there's data. And each of these points, it comes from this tabular structure, this Julia data frames object. So for example, if I focus in on this point right here, the x value is 3 and the corresponding y value is a little bit above 5. It's not conveying much information to me other than that this bunch is different than this bunch, maybe. I can't see the differences in species. I don't know what the X label is and the Y label is, so let's go ahead and fix that. Now, if you've been watching this series, you should at least know how to give labels to the X and Y axis. So if I type X label, the X values are petal length. So I'm going to give this the string petal length, comma, and then I'll do the same thing for the Y label, except for in this case, I'm going to say sepal length instead of petal length, comma. So now if I select all, Shift Enter, I see that I have now appropriately labeled axes here. So I'm also going to give it a title, the iris dataset, make sure to put a comma there, select all and run, got a title now. But still, I can't tell the differences in the species. And this is really important for me and for those of you that might want to practice machine learning to be able to differentiate what species are what. Now, luckily, the scatter function has a great keyword argument called group. And group is going to be an array of the same length as X and Y that assigns to each XY pair a given value, whether it's a string or a numerical value. So I can just go ahead and say labels is equal to iris.species, since that's going to be the column of the associated labels for each point. And I'm going to then, inside of scatter, say group is equal to labels. All right, so now if I run that, nice. I see that now this cluster over here are the Setosa flowers. We have versicolor and virginica kind of mixing up over here. But then I see that my legend is in the way. I can't tell if there's versicolor or even Setosa hidden behind that. So I need to move it. So the way that we can do this is by using the keyword argument legend and then give it the symbol. Well, my first guess is left, because the left of this figure doesn't have points that would get in the way. So let me just try that and see what happens and type left. All right, so I'm gonna go ahead and save, select all, and then run. Okay, now it's covering the Setosas. Maybe I should do top left because I want it over here. And that's my first guess. So I'll save that, select all and run. Good, it's out of the way. So whenever the legend is in the way, you can move it according to giving it you can move it by assigning the appropriate symbol for its placement. I like that. So next up, I sort of want to change the colors of my dots, of my markers. And currently red, yellow, green. I'd like it to look more Julia-esque. like the symbol. We have the green, the purple, and the red. So if I go and I find my colors, hopefully I have it saved up here somewhere. All right, so those are the Julia colors. I want one of them to be that type of purple, which looks like dark violet. Okay, so if I come up here, oh, how do I assign the colors to these groups? Well, this is actually easy. If we type color, we can give this a row vector or an array with entries not separated by commas. So I'm going to say dark violet right there, and then press space. So the next entry will be the assignment to the next species. So if I go back to my colors and now I want to find a green type of color, it looks like that one. Maybe, I don't know, what would be the best one? Maybe green 3, because I want it to pop a little bit. Green 3. And then my next group, I would like to have, so I have some type of red, maybe red 3. Okay, red 3 looks good. So give it the symbol red 3, comma, let me select all and run. Nice. So now we have Julia-esque colors. But maybe I want the sizes of these markers to be bigger. So we can specify the size of the markers by the marker size keyword. And again, I can give this a row vector. For example, I can do like 10 space 7 space 13 comma, save it. Let's run it and see what happens. All right, we have sizes, great. But if I look over here with the Virginica and Versailles color, I see that there's overlap and I can't see all the greens that might be hidden underneath the reds. This is a good case for using the alpha keyword argument. And the alpha keyword argument is basically telling you how transparent the markers are. This value is a number between 0 and 1, where 1 tends to be this color, and as you decrease the value, it becomes more and more transparent. So maybe I want to choose something like 0.60. Put a comma there, and then run it. I see that now there's some transparency in my markers. I like that. However, now my markers are kind of sticking outside of the Euclidean plane that's viewable. So if you've been watching my videos, you should know that we can set the xlim to fix this. So xlim is a tuple where the first entry is where you start. So in this case, it looks like I'm going to start at 0. And then the right entry is where I want to stop. So maybe 7.5. And then for the ylim, same concept. Maybe I want to start at 3.5 and then end at 8.5. Put my comma there, save it, select all, shift enter and run. Great. This is looking pretty good. Maybe next up I want to change the marker stylings, right? I just have simple circles. So I can do marker shape, I think, which again can be a row vector. So I know a few offhand, so maybe hex is one, maybe *7 is another, and then maybe cross. Put a comma there, save it, run. There we go. I can no longer see my Virginica flowers, so maybe I want a lighter theme and do ggplot2. Select all and run. So now I can see them. I like that. Okay, so this looks pretty good. Maybe I'll try another theme real fast. So I was going through the themes before recording this. Lime. See what happens if we do the lime theme. I can barely see anything. I'm going back to ggplot. Okay. So I'd like to point out now that we have kind of arbitrarily chosen the sizes for each group. Another way that we can do this, especially if the groups aren't necessarily ordered, because currently everything is ordered, like the XY pairs are uniquely assigned with a given species. Maybe we would like, I don't know, to associate the size of the markers with another feature. This is a way of visualizing three-dimensional data in the plane. We plot two features or two measurements and then give a size to each corresponding marker, a value related to another one of the features we haven't used. So for example, we've used petal length and sepal length. Maybe we can associate the size of each marker with its corresponding sepal width. So I'll say sizes is equal to iris dot sepal width, which now accesses this full column. And now, in place of marker size, instead of giving it that three-dimensional row vector, I can just do sizes, which is now an array that gives each point a different value in this column. So if I save that, run it, too small, but maybe if we scale it, nothing wrong with that. We can just multiply each of those entries by 3.0. And then we get a better looking plot. Maybe I want to make the transparency a little bit more and decrease my alpha. That cross though, that is not good. Maybe is O1? I'm not sure. Yeah, there we go. And then I think I want to go back to the dark theme. Looking good. Okay. So this is all you need to know about scattering. Now, if you wanted to do this in a layering structure, you can do the same bang operation or bang function calls that we did in the previous videos. For example, I know that the first 50 rows belong to Setosa, okay? So I'm gonna now make a very similar plot using the layering approach that I've mentioned in previous videos. So the first 50 rows of X and Y belong to Setosa. The first 50 rows of species are Setosa, or the labels. The first 50 rows of sizes are Setosa's sepal widths. Okay, so if I do this and I say I want the X values 1 through 50 and the Y values 1 through 50. X length can stay the same, petal length, sepal length. Title's good. I don't need a group anymore, and you'll see why. Legend top left. Color is only going to be one species, because I'm only looking at the first 50 rows, so I can get rid of that. Sizes will be 1 through 50. Marker shape will be hex. Alpha is that, DPI is that. Save that and run it. I see that I have just isolated the Setosa species, except for the labels off because I took away the group. So I can fix that by calling the label keyword argument and giving that Setosa. So now if I run this, my legend is good. And I can slowly now stack on top of this figure. Recall that when you call a scatter function or a plot function from Plots.jl, it makes a figure, and then you can modify it by calling a similar function with the bang or the exclamation mark. So for example, I'm going to look at 51 through 100 now, which I know are the Versailles color, the other species. So X 51 through 100, Y 51 through 100. I don't have to redo the X limbs and the labels and the title because that was set in place by this figure. All I have to do is add the attributes of the markers that will be placed on this figure. So for example, the color, what did I choose it to be earlier? It was like red 3, I think. Marker shape equals to, what was it? Cross 7 or something? What did I have? Well, this is why I provide documentation down below. Let's see. Type, stride. Here goes some marker shapes. Oh, star 7 is what I had. So if I go back over here, star 7. And then for marker size, this will be the sizes array from 51 to 100. And then the label is going to be Versailles color, since I already know that that group of species lies on those rows. I don't have to, oh, the alpha argument, alpha equals to 0.40. I don't have to change the DPI. Save that and I run it. I see that those are my Versailles color. Okay. Maybe I just want it to be red. For now, I forget what I did earlier. All right. And then as you can guess, the Virginica are the last 50 columns. So I can literally just copy that function, come down here, paste it like that, and then do 101 to 150, 101 to 150. I'll just do green for now to save time. Marker, I remember this one was the O, 101 to 150. And these are Virginica species. Save that, select all and run. What is going on here? Something is off. Can I not see it? Let's see. ggplot2, save, select all, run. Oh, am I getting an error? I am getting an error. That's what was going wrong. Oh, I typed a 0 instead of an O. I'm being dumb. Select all and run. There it goes. Oh, where's my title? Again, we can just do this. Put that bang there. Title equals to the iris dataset. Save that, run it. There it goes. Okay. So this has been your introduction to scattering data. So at this point, if you've been watching my series, you should know how to plot line plots or line charts with series data. You should know how to plot functions, so the basic mathematical functions, and you should now know how to scatter series data. Okay, thank you for watching, and I'll see you next time.